Hey 7th graders, it's Mr. Sarley. Welcome back to your YouTube homework review. Use this to either go over all the problems if you want, or just skip to the problems that you really want to make sure you got the answers correct. So last week on Thursday, we took a state test benchmark, and something you probably saw is we need to be really, really good with fractions and decimals. So I'm going to start really going over this on the homework so that by the time we make it to April, if you're doing your homework every night, you're going to be at the state test level. And this week, we're starting off a little easy, but trust me, it's going to start getting tricky. So make sure you're checking your work all the time. Alright, so the first problem says 1/3 plus 1/3. I'm not going to go over all these, I'm just going to go over the first few. So when we're adding fractions, we have to remember that this would be totally incorrect. Someone who's doing this isn't really thinking about fractions, they're just adding the ones and adding the threes. A better way to think about it would be like, we have a whole, and it's broken up into thirds. Each one of these is a third. So if we have 1/3, and then we add another third, it's correct that we're going to add the 1 and the 1, but that denominator stays the same, because the denominator tells us how big the pieces are, and that's all it tells us. The numerator tells us how many, so 1 and 1 would be 2. So I'm sure that one was easy. And down here, this problem is actually the exact same as the one above, it's just written differently. If we have 2 of 1/3, that's basically like saying 1/3 plus 1/3, just in a different way. So this answer should again be 2/3. Now, you guys probably learned back in, I'm going to say 4th grade, that you could also think about this like 2, and then we should rewrite 2 as a fraction, like 2 over 1, and multiply it by 1/3, and it equals 2 over 3 that way. You could totally do it that way, but honestly, if you're just thinking 2 times 1/3 is just the same as that repeated twice, then you don't have to work nearly as hard. So now let's use those two ideas and fly through the next ones. So 1/4 plus 1/4 plus 1/4, that would be 3/4. And 3 times 1/4 is the exact same as that. 3 times 1/4 is like 1/4 repeated 3 times, which would be 3/4. 1/5 plus 1/5 would be 2/5. And 2 times 1/5 is the exact same as that. It just means we're going to have 2 1/5s, which is 2/5. So you could probably fly through the rest of those, make sure you're checking your answers. Alright, something we need to be really good at from 6th grade is ratios. And hopefully Jeffrey's okay with this joke that I made last year on Halloween. This was the problem we did. But Jeffrey decides to scare small children on Halloween by dressing up as Freddy Krueger. Hiding behind a bush, he scares 18 children every 12 minutes. At this rate, how many children will he scare in 24 minutes? So just a quick reminder, we have a ton of strategies we could use to solve a ratio problem. Probably the main two Vicuña and I used a lot last year were the double number line and the ratio table. So when we have a problem like this, we're kind of looking for the ratio. And it says, hiding behind a bush, Jeffrey scares 18 children every 12 minutes. So whenever it's something for every something else, it's talking about a ratio. And this ratio is going to be 18 children to, or for every, 12 minutes. And now we can use this ratio and find equivalent ratios to it to help us answer questions. This first problem is not too hard. I'm just going over it to make sure we really get it. It says, at this rate, how many children will he scare in 24 minutes? So on a double number line, I'm going to put the two variables. It's 18 children for every 12 minutes. And a double number line always starts at 0. And then I'm going to go ahead and I'm going to place 18 on top because that's the children and 12 down by the minutes. And now we can find equivalent ratios by scaling that, by just going by the multiples. So on top, I'd be adding 18. 18 and 18 would be 36. The next one would be 36 plus 18 would be 54. Down here, I'm going by the multiples of 12. So in 12 minutes, Jeffrey scares 18 children. In 24 minutes, Jeffrey scares 36 children. And in 36 minutes, he scares 54. Now, the question asks about 24 minutes, and that's right here, and it looks like he scares 36 children. If you wanted to solve this on the ratio table, we would put children and minutes again. We would start with that first 18 children for every 12-minute ratio, and then from here, I know that I want to go to 24 minutes, and I know that if I double or multiply the first ratio by 2, it's going to give me 24. So if I do that to the top number, I would also get 36, which I know is the right answer. Finally, I bet some of you just did this. 18 to 12 is the same as 36 to 24, and you just scale down by the multiples that way. Alright, so at this rate, how many children will he scare in 6 minutes? So I'm going to go back to my representations. We want to know 6 minutes. So remember with ratios, you can scale them up, but you can also scale them down. And there are a lot of ways to do this. One way would be just to take our starting ratio, which was 18 children in 12 minutes, and then I want to get to 6 minutes, so I have minutes and children, so I'm just going to divide this ratio in half. So 18 children are scared every 12 minutes. That's the same as 9 children getting scared every 6 minutes. So 9 kids would be the answer, but check out all the ways we could have figured it out. The cool thing about double number lines is you can kind of break them in half, or in any part, really. So between 0 and 12 minutes would be 6 minutes. Between 0 and 18 minutes would be 9. And there again would be our answer. 9 kids in 6 minutes is right here. 9 kids in 6 minutes. Finally, if we wanted to show it in a ratio table, we start off with 18 children for every 12 minutes. And we show our division this way. And when we do that, we get this same exact answer. 9 children are scared in 6 minutes. At this rate, how many children will Jeffrey scare in 30 minutes? So many ways to do this problem, but now I know I'm looking for 30 minutes. And if I come back to my double number line, I see that down here it goes 0, 12, 24, 36. It skips 30 minutes. But then, remember, I broke this ratio down to get 6 minutes and 9 children. So now I'm just going to break them all in half and go by those ratios. So 6, 12, 18 minutes would go in the middle, 24, 30, which is what I want, and 36. And now up here we have 9, 18, going by the multiples of 9, 27, 36, 45, and that looks like what we want. It looks like 45 kids are scared in 30 minutes, and that would be using the double number line. But let's use a couple other strategies too. I know some of you really like to use ratio tables like this, and look how cool they are, right? So first, we can break it down, because we're trying to get to 30 minutes, but 12 is not going to make it to 30. So first, it makes more sense to break the ratio down to something that works. We get that ratio we got earlier of 9 children scared in 6 minutes. And now, can we get from 6 to 30? We can, and I notice that we can multiply by 5. So 9 times 5 would give us 45, and look at that. We have a new equal ratio, and that's that answer. Finally, a more advanced strategy for all of you still paying attention and just trying to think at a higher level. There's also a way to write an equation for this problem. I notice that there's a connection between the minutes and the children. There's a constant of proportionality, or a factor we can multiply 12 by to get 18, or 6 by to get 9, or 30 by to get 45. And it's a little tricky to see, but what I notice is we can take the number of minutes and multiply it by 1.5. and then it's going to equal the number of children. So if we had 6 minutes times 1.5, I know that that should equal 9, and if you do the math, it should. So to solve this problem that we want, you could do 30 minutes times 1.5, and that's 45, which again is another way of getting our answer. So hopefully for some of you that higher level strategy makes sense, even though our scale or our constant of proportionality is a decimal. Alright, so hopefully that made sense, and our secret word, I'm just going to continue with Star Wars, and I probably could forever, but I promise this is the last week. The secret word is the new droid in the new movie, and his name is BB-8. See you guys tomorrow.